Hi everybody, here's lesson 11, which is solving by completing the square. So today we're officially adding completing the square to our toolbox in solving quadratic equations. Right now we have the zero product property, but factoring doesn't always work. Completing the square always will work. It might be ugly, but we can always complete the square to solve any quadratic equation, which is the nice thing about this process. So before we get to that, let's review inverse operations, because that's going to go hand in hand. Inverse operations is going to go hand in hand with completing the square. So remember, we can use inverse operations when we see x once, and we can work our way to get to that x. So I'm going to add 36 to both sides to start solving this. As tempting as it is, you can't distribute, you have to divide by 2. And here's where we undo squaring. How do I undo squaring? I take the square root. So that gets rid of that squared for me and leaves me with x minus 2 equals, I hope you remembered, plus or minus the square root of 28. Remember, when we take the square root during inverse operations, there are two solutions. There's a positive one as well as a negative one. And then my final step is to add over that 2 when we stick that right in front. So x equals 2 plus or minus the square root of 18. But look here, simplest radical form. I have an irrational number as my answer, which means I need to tear that radical 18 apart. How do I tear 18 apart? What perfect square goes into 18? 9 times 2. So 3 square roots of 2. So my final answer is x equals 2 plus or minus 3 radical 2. Those are my two answers. What do I mean by two answers? 2 plus 3 radical 2, that's some crazy decimal. And 2 minus 3 radical 2, that's another crazy decimal. Instead of writing it twice, we just write it with that plus or minus. So leave your answer with the plus or minus, unless for some reason it's split up, but you're not going to see that. So the purpose of completing the square is to take a trinomial like I have here and turn it into a perfect square so I can use inverse operations. Solve this equation by completing the square. So what I'm going to do is I'm going to look at those first two terms and make my square. X squared, cut the middleman in half, plus 3 gives me a magic number of 9. So here we go, x squared plus 6x plus 9. But if I add 9, I also have to counteract with a negative 9. Minus 12 equals 0. Now I'm actually going to complete the square. I'm going to factor this as x plus 3 squared. I made a perfect square here, literally. Minus 21 equals 0. I'm done completing the square. Now we shift into inverse operation mode. Now we switch into getting x by itself. So we add 21. X plus 3 squared equals 21. We take the square root. X plus 3 equals plus or minus radical 21. And then we subtract 3. So completing the square involves kind of two different steps. Step 1 is actually completing the square, and then once we complete the square, we use inverse operations to get our solutions. So is that simplest radical form? Can I tear apart radical 21? 3 and 7, but those aren't perfect squares. But notice, though, it says to the nearest hundredth as well. So negative 3 plus the square root of 21. If I type that into your calculator there, negative 3 plus the square root of 21. Type that into your calculator and get a decimal for it. Or negative 3 minus the square root of 21. So let me just grab my calculator here. And again, if you don't have your calculator with you, download the Desmos app, go to desmos.com. We've used it in class before. I can email me and I'll help you figure it out. So to the nearest hundredth. Hundredth is two places. For the plus version, I got 1.58. And for the minus version, I got negative 7.58. Those are approximately my answers. Those are the numbers that make me equal 0. So why was factoring not an option? The solutions were irrational. We can only factor if the solutions are actually rational, but we don't know that from the start. I mean, we could have tried factoring it. It wouldn't have worked. But if you ever get irrational answers or simplest radical form or nearest hundredth, that tells you you can't factor it. Those are signs that you have to use completing the square. So there's nothing really new in this lesson. This lesson's really just taking completing the square, and now instead of just doing it, we're going to use it to solve an equation. So I've got some problems for us to try, and then we'll be done with completing the square. So solve these quadratic equations by completing the square. Express your answer in simplest radical form. So here we go. Ooh, this first one, hopefully you notice there's a 2 in front of it, which means I need to factor out a 2. X squared plus 6x. I had to divide by 2 there to get this equal to 0. So now we complete the square. Cut the middleman in half. 3 times 3 is 9. 9 is the magic number I need to add in to complete the square. X squared plus 6x plus 9. That's the magic number I needed to add in. But remember, it's not really a 9. It's really an 18. 2 times 9 is 18. So on the outside here, I'm going to put minus 18 there. Be careful counteracting when there's a leading coefficient. That's what we spent last lesson exploring. And then there's a plus 5. So complete the square. That's my square there. What square did I make? X plus 3 minus 13 equals 0. We're done completing the square. Now it's time for inverse operations. So I'm going to move over that 13 by adding it. I'm going to divide by 2. You can write 6.5. I'm going to leave it as 13 halves, but 6.5 works too. I take the square root plus or minus radical 13 over 2. And then finally, x equals negative 3 plus or minus the square root of 13 over 2. Those are my solutions. Those are my solutions there. X, I'm going to write it over here so it's bigger, plus or minus the square root of 13 over 2. So when we complete the square, it turns into an inverse operation problem. I'll do one more with you and leave you the 2 to try here. It's not equal to 0. We can make that happen. There we go. Now it equals 0. Complete the square. Draw a box. Cut the middleman in half. Gives me a magic number of positive 1. So let's add that positive 1 in. I can't just plus 1, I also have to minus 1. Factor. How do I factor it? I look at the sides of the box. And I'm done completing the square. Now it's time for inverse operations. It's time for inverse operations, so I'm going to add the 3. Take the square root. And then add. Get x by itself. I have x minus 1, so I'm going to add the 1. 1 plus or minus the square root of 3. Those are my 2 solutions. They're irrational. It's an irrational number because the sum of a rational and an irrational is irrational. So at this point, pause the video and try the next 2. Pause the video and try these 2 here. And then compare your answers with mine. Did you actually pause the video? I hope you did. I hope you actually tried them and just didn't let that second pass by. So hopefully you drew a box and cut the middleman in half. And hopefully you got 9 as your magic number. I'm going to add in that 9. And hopefully you subtracted that 9 to counteract that plus 9 there. And then you factored Factor those three, combine those two. And now it's time for inverse operations. X plus 3 squared equals 22. We take the square root. But remember, when you take the square root, you throw a plus or minus in front of that. And subtract. Oh, did I subtract right there? Yes. I can do math, I promise. -3 plus or minus the square root of 22. The only way I know how to tear apart 22 is 2 times 11, but those aren't perfect squares. So hopefully you got -3 plus or minus radical 22. And the last one here. Draw a box. Complete the square. This is a square of x plus 2, which gives you 4 as the magic number. So I stuck in a 4, which means I need to take away a 4. And that leaves me with x plus 2 squared minus 20 is 0. So I'm done completing the square, which is we spent the past 2 days learning how to do. Now it's time for inverse operations, which was the day before that. Add 20 over. Take the square root. Plus or minus radical 20, and then subtract that too. -2 plus or minus radical 20. We got x by itself. We're basically done solving it, but hey, it said simplest radical form. So hopefully you recognize now 20 breaks up as 4 times 5. We've done this one a couple times. So that's actually my final answer, because I had to break up that square root there. I hope you found these problems to be pretty straightforward, and it's nicer than factoring because you don't have to think about what multiplies and adds to this. You do the process, and it's the same process every time. So something like number 4, they ask on the Regents exam a whole bunch. Which of the following equations has the same solutions? So look, same answers. I start with a trinomial, and I turn it into a square. Well, let's think about it. They're not explicitly telling us what to do here, but I'm starting with a trinomial and turning it into a square. Guess what process that is? We need to complete the square. So they're not telling us to complete the square, but they're hinting at us by giving us our answers that look like this. The way that you get answers that look like that is by completing the square. So let's do it. Let's complete the square over here. X squared, 3x, 3x. I feel like it's the same numbers every time. 3 times 3 is 9. 9 is the magic number to add in. X squared plus 6x plus 9. I can't just add 9, I have to also subtract 9. I picked 9, so this factors nicely. Oh, x plus 3 minus 21. So my next step here is, look, when I add over the 21, I'm done. I turned a trinomial into a perfect square. X plus 3 squared equals 21. So New York State asks us questions like that all the time, saying which of these is equivalent to, which equation is equivalent, which has the same solutions. And they'll ask you, they're hinting at you to complete the square. So at this point, try the homework problems. Stop the video. I got only, what is that, 4 questions for you to do here. Should be short and sweet. Now that we're done with all the completing the square lessons, you'll find problem set, I want to say it's 18. You now know all the content that you need to know to solve all those problems. Way to make it through week 1. See you in week 2.